In 2006, Pluto was officially stripped of its title as the ninth planet in our solar system. It was small, distant, icy, and, apparently, not important. That's what we were told. That Pluto didn't matter. That it was just a frozen rock at the edge of the solar system. But then, something happened. NASA sent a spacecraft, New Horizons, hurtling toward Pluto at 58,000 kilometers per hour. And what it found when it arrived shattered everything we thought we knew. Because Pluto wasn't dead. It wasn't just a rock. It was alive, geologically speaking, and maybe even more than that. There were mountains of solid water ice, a heart-shaped basin with no impact craters, and signs, real, measurable signs, of something moving beneath its surface. But let's back up for a second. You see, for most of human history, Pluto was a blurry dot. Even the Hubble Space Telescope could only give us a few muddy pixels. So we believed what textbooks told us, that Pluto was small, quiet, cold, and irrelevant. And maybe that's exactly what they wanted us to believe. Because the more we've learned about Pluto, the stranger it becomes. Why does it have atmospheric haze, multiple layers of it, stretching 200 kilometers high? Why does it have ice volcanoes larger than any on Earth, yet no internal heat source to power them? And why, despite everything, we haven't sent a single mission back? Some scientists believe Pluto may harbor an underground ocean, insulated by exotic ice and radioactive decay. Others believe it may even have prebiotic chemistry, a precursor to life. But if that's true, then Pluto isn't just interesting, it's dangerous to ignore. Because it would mean we've been wrong, catastrophically wrong, about what counts as a planet, about where life might hide, and about what's lurking in the coldest corners of space. So, here's the truth. Everything we knew about Pluto was based on assumptions, not evidence. And now that we finally have the evidence, the story has changed, drastically. This is the story of Pluto, the planet that was dismissed, forgotten, and then revealed to be one of the most mysterious worlds we've ever encountered. And if you think this is just about science, you're in for a surprise. Because there are things we've found, images, anomalies, data, that have quietly disappeared from public view. And if that doesn't make you curious, it should. For over 70 years, Pluto was more mystery than world. Discovered in 1930 by Clyde Tombaugh, it was hailed as the long-sought Planet X, a missing world tugging at the orbits of Uranus and Neptune. But from the very beginning, things didn't add up. Pluto was too small, too dim, too light to cause the gravitational effects astronomers were seeing. In fact, what we called Planet X may have never existed at all. Pluto, it turns out, was a cosmic coincidence, or at least that's what the textbook started saying. Over time, the excitement faded. Pluto's status was quietly downgraded from major discovery to just another icy object. By the 1990s, telescopes were spotting dozens of Pluto-like objects in the outer solar system, members of what we now call the Kuiper Belt. Pluto, once the ninth planet, began to look ordinary. And then came 2006, the year the International Astronomical Union officially demoted Pluto to a dwarf planet. The criteria? It hadn't cleared its orbit of debris, something Jupiter, Earth, and even Mars have done. The decision sparked outrage. People protested. Even some scientists were furious. But the damage was done. Pluto was out. And that's where the myth began. Because from that point forward, the world was told Pluto didn't matter. It wasn't interesting. It wasn't worth exploring. But the truth? No one had ever seen Pluto up close. All we had were fuzzy images, computer models, and educated guesses. Everything we knew about Pluto was based on assumption, not observation. We thought it was just a cold, dead rock. We thought it was featureless, lifeless, and scientifically boring. We thought wrong. The irony? While scientists debated whether Pluto deserved to be a planet, NASA had already launched a mission to find out what it really was. That mission was New Horizons, launched in 2006, the same year Pluto lost its status. It would take nearly a decade to reach Pluto, traveling over 3 billion miles through the void. And when it finally arrived in 2015, everything changed. Because what New Horizons saw was not a dead world, not a frozen rock, but a place with stunning geology, complex layers, and signs of activity no one had predicted. Pluto had fooled us all. But maybe, just maybe, it hadn't fooled everyone. There are those who say Pluto's secrets were always more than just geological, that something out there didn't want us to look too closely. And as we go deeper into what New Horizons discovered, that theory becomes harder to dismiss, because some of the things we found out there still haven't been explained. Before New Horizons reached Pluto, the official narrative was simple. Pluto was a relic, a leftover chunk from the formation of the solar system, small, cold, and inert. NASA's models predicted a frozen ball of rock and ice, maybe a few craters, maybe some cracked terrain from ancient collisions, but nothing more. Certainly nothing active, nothing strange. Pluto was supposed to be dead. In fact, many scientists questioned whether it was even worth studying. Why spend billions to fly past a glorified snowball? But deep down, a few dissenting voices weren't so sure. There were whispers, strange fluctuations in light curves, unexpected orbital behaviors, unusual surface reflections that didn't quite fit the model. Still, most of the scientific community dismissed them. Artifacts, they said, glitches in the data. And then, in July 2015, New Horizons flew past Pluto, and the world changed. What the spacecraft captured was unlike anything anyone had predicted. First, there was the heart-shaped region, now known as Tombaugh Regio. It wasn't just visually striking, it was young. So young, in fact, that it had no impact craters, suggesting recent resurfacing. But how? Pluto was supposed to have no geological activity, no atmosphere to speak of, no internal heat. Yet here it was, a landscape that looked freshly formed. Then came the mountains, towering peaks of solid water ice, some reaching 3 to 4 kilometers high. These weren't random piles of debris. They were structured, stable, and massive. Even more shocking? The presence of ice volcanoes, also known as cryovolcanoes. Massive domes like Wright Mons and Pickard Mons showed signs of possible eruptions. Eruptions of what, exactly? Not lava, but slushy mixtures of water, nitrogen, ammonia, liquids that can exist only under very specific conditions. Conditions that shouldn't be present on Pluto, not if the models were correct. And then, there was the atmosphere. New Horizons revealed a thin, layered haze extending hundreds of kilometers above the surface. It wasn't just a fog, it was complex, with multiple distinct layers, likely made of hydrocarbons. How could such a small, cold world maintain this? How was it replenishing its atmosphere over time? The evidence was piling up. Every photo, every data point, every anomaly. Pluto wasn't dead. It wasn't simple. It wasn't irrelevant. It was alive, geologically, chemically, and, some say, possibly biologically. For NASA, this was a turning point, because everything they had assumed about planetary heat, geology, activity, was crumbling. But here's the question no one wanted to ask out loud. If Pluto proved our models wrong, what else are we wrong about? When the first high-resolution images of Pluto came in from New Horizons, mission scientists were stunned, literally speechless. It wasn't just that Pluto was geologically active, it was beautifully active. One of the most iconic images captured was of Tombaugh Regio, the heart-shaped basin stretching nearly 1,600 kilometers across. On one side of that heart lies Sputnik Planitia, a vast, smooth plain of nitrogen ice. Here's where it gets strange. This area shows no impact craters, which means it's geologically young, possibly less than 10 million years old. In cosmic terms, that's practically yesterday. The plain isn't static. There are clear signs of convection currents with ice cells that seem to slowly churn over time, like boiling water, but at minus 230 degrees Celsius. And get this, Pluto doesn't have enough internal heat, at least not according to traditional models, to cause this kind of movement. So, what's driving it? Then came the discovery of Right Mons, an enormous ice volcano rising about 4 kilometers high. But unlike typical volcanoes on Earth, this one wasn't made of molten rock. It seemed to be built from frozen water, ammonia, and other ices, materials that would melt and erupt under Pluto's frigid conditions only if there were a hidden heat source below. But where is that heat coming from? Some theorists point to radioactive decay in Pluto's rocky core. Others believe that tidal forces caused by Pluto's largest moon, Charon, may generate internal friction. Still, that doesn't explain everything. For instance, the presence of layered haze in Pluto's thin atmosphere, captured in backlit photos by New Horizons, indicates chemical complexity far beyond what was expected. We're talking 20 distinct haze layers forming from interactions between solar radiation and Pluto's surface. These layers scatter sunlight in such a way that, at certain angles, Pluto glows with a bluish halo, like a dying world wrapped in mystery. One image showed something even more bizarre. Shadowed ridges and troughs on the surface that resembled ice blade formations, towering walls of ice that could rise hundreds of meters tall. And they're not random. They appear aligned, stretched across Pluto's landscape like scars from an unknown force. But perhaps most unsettling were the hints of possible subsurface oceans. Yes, oceans. Data from New Horizons instruments detected gravitational anomalies, subtle shifts in Pluto's gravity that could suggest a vast underground reservoir of liquid sealed beneath kilometers of solid ice. If true, this means that even in the coldest regions of the solar system, life-sustaining environments could exist, hidden, protected, and utterly alien. And that raises the biggest question of all. Did Pluto once harbor life? Or does it still? For decades, the idea of liquid water existing on Pluto was considered laughable. At minus 230 degrees Celsius, nothing should be able to stay liquid, not even antifreeze. But then came the data. New Horizons didn't just take pictures. It measured subtle gravitational shifts, mapped surface flexing, and analyzed surface chemistry. And all signs pointed to something unexpected: a warm interior. More specifically, a liquid ocean beneath Pluto's icy crust. According to several studies beneath Sputnik Planitia's nitrogen ice plains, there may lie an underground ocean that spans hundreds of kilometers. Not just a pocket of slush, but a global ocean, kept warm by radioactive decay and insulated by exotic ices like ammonia hydrates. This isn't science fiction anymore. Peer-reviewed papers now seriously consider Pluto to be a member of an exclusive club, Ocean Worlds, alongside Europa, Enceladus, and Titan. And here's where things get even stranger. Some of the features on Pluto's surface, the cryovolcanoes, the stress lines, the possible tectonic movement, suggest that this ocean is still active, still moving, still shifting, and possibly still supporting prebiotic chemistry. Because where there's liquid water, there's potential for life. Let that sink in. On a planet that was dismissed as a frozen rock, scientists now theorize that life may exist deep below the surface, protected from radiation, nourished by minerals, and thriving in complete darkness. Microbial life, extremophiles. Life not as we know it, but life nonetheless. And if that's the case, then Pluto isn't a dead world. It's a hidden world, quiet, secretive, and waiting to be understood. Some researchers go even further. They speculate that Pluto may have once had surface oceans billions of years ago when the solar system was young and chaotic. Perhaps something emerged, evolved, and then retreated underground as the planet cooled. Others argue that Pluto's internal structure, rocky core, water shell, icy surface, is eerily similar to certain types of rogue planets. Objects that were once part of solar systems, ejected into deep space, now drifting alone. Could Pluto be one of them? A captured wanderer? A fragment of something older? A messenger from beyond? The more we learn, the more the questions multiply. And the more we realize, Pluto was never boring. It was just hiding. In 2015, New Horizons gave us the first clear glimpse of Pluto, its surface, its atmosphere, its secrets. The images captivated the world. The data stunned scientists. The implications were staggering. And then, nothing. No follow-up mission. No orbital probes. No landers. Not even serious funding proposals. For a world that turned out to be far more complex than anyone imagined, the silence was deafening. So why hasn't NASA gone back? Publicly, the answers are familiar. Pluto is far. It's expensive. And there are other priorities. But let's take a closer look. NASA's own team members from the New Horizons mission have been pushing for a return, proposing a new orbiter that could map the planet in detail, study its atmosphere over time, and confirm the existence of a subsurface ocean. The technology exists, the science is compelling, the public interest is high, and yet, nothing moves forward. It's not just a lack of budget, it's a lack of urgency. Compare that to Mars, where we've launched dozens of missions, rovers, helicopters, and orbiters. Or Europa, which has a flagship mission set to launch soon. Why not Pluto? Here's a theory. What if Pluto revealed too much? What if the data it returned didn't just challenge scientific models, but political, historical, or even existential frameworks? Because remember, New Horizons discovered things that shouldn't exist. Ice volcanoes with no heat source, a thin, structured atmosphere with complex hazes, gravity anomalies suggesting liquid oceans under a shell of frozen nitrogen, surface features that look engineered, ridges, aligned formations, hexagonal patterns. Some of those images were quietly downplayed. Some data sets still haven't been made fully public. It's not a conspiracy. Not exactly. But it's also not transparency. And then there's the question of the downgrade. In 2006, the very year New Horizons launched, Pluto was officially demoted to dwarf planet status. Many scientists still question that decision. Was it scientific timing, or was it something else? Some speculate that the demotion was strategic. If Pluto turned out to be more than expected, better to have it labeled as less important, less prioritized, less threatening. Because if Pluto is a world with oceans, with chemistry, with potential life, then it deserves attention. It demands exploration, and maybe, just maybe, someone didn't want that. Maybe the silence isn't because Pluto isn't interesting, but because it's too interesting. So now we ask the question that no textbook dares to answer. What is Pluto? Really? Because the more we learn, the less it makes sense. Let's start with the basics. Pluto is small, just 1,476 miles across, barely the size of Australia. Yet, it has 5 moons, including one, Charon, that's so massive it forms a binary system. Pluto and Charon orbit a shared gravitational point in space, not inside Pluto itself. That's rare, that's weird, and that's just the beginning. Unlike most planets and moons, Pluto's surface shows no signs of catastrophic impacts. Its landscape is preserved, structured, evolving, almost as if it's being protected. And then there's its orbit. Pluto doesn't follow the same orbital plane as the other planets. It's tilted. It's eccentric. It even crosses Neptune's orbit but never collides, thanks to a perfectly timed resonance. Coincidence? Or cosmic choreography? Some scientists have proposed that Pluto didn't form in our solar system at all, that it's a captured object, ejected from another star system and snared by the sun's gravity billions of years ago. If that's true, then Pluto is a visitor, an alien world, literally. Other researchers point to its internal ocean, layered haze, and geologic activity, suggesting that Pluto may not just be alive geologically, but artificially maintained. What if Pluto is an ancient biosphere, a sealed capsule from a lost civilization, a vault of data drifting through space, disguised as an icy rock? Sound ridiculous? Consider this. Pluto has no reason to be warm enough for liquid oceans, yet it might have them. It has features that resemble alien megastructures, aligned ridges, geometric patterns, and cryovolcanoes placed in near-symmetric positions. Its atmosphere is chemically rich, layered, and reactive, behaving like a controlled system. And if that weren't enough, some of the radio transmissions received from New Horizons as it passed Pluto contained brief anomalies, minute distortions that engineers initially chalked up to cosmic interference. But were they? Or were they something else? A code? A signal? A response? No one's saying it aloud. But behind closed doors, the data tells a different story, because Pluto isn't just a leftover, it's not a mistake. It might be a message, a warning, a memory, a test. And if that's true, we may not be looking at the edge of the solar system, but at the edge of understanding. So, here we are, nearly a century after Pluto's discovery, and we still don't know what it truly is. Is it a frozen relic? A planetary orphan? A rogue world captured by gravity? Or something built, designed, intended to be discovered only when we were ready? We tried to forget Pluto. We stripped its title. We minimized its importance. We looked the other way. But Pluto didn't go quietly. It fought back, with volcanoes of ice, with oceans beneath miles of frozen crust, with an atmosphere that glows in blue haze under the distant sun. It whispered secrets through gravitational anomalies. It screamed through geological features that defied logic. It held up a mirror to our ignorance, our arrogance, and dared us to look again. And now we're faced with a choice. We can continue pretending that Pluto is just another icy rock. We can bury the data, delay the missions, and dismiss the questions. We can cling to old models, comfortable, safe, incomplete. Or we can ask, what else have we been wrong about? If Pluto, a place we were so sure was dead, is alive, then how many other dead worlds are quietly pulsing beneath their icy shells? If a distant dwarf planet can have oceans, volcanoes, and atmospheric chemistry, then how many hidden biospheres exist in the void? If Pluto was downgraded not because of science, but because of what it might reveal, then what else has been kept from us? There is so much we don't know, so much we've chosen not to see. But out there, at the edge of our solar system, a small, cold, forgotten world is still turning. Still evolving, still waiting. And if we dare to go back, not just with instruments and probes, but with open minds, we might find answers to questions we haven't even learned how to ask. Because the truth is this: Pluto was never the end. It was a beginning, a crack in the story, a glitch in the narrative. And maybe, just maybe, a doorway to something far bigger than we ever imagined. If you believe the truth deserves to be seen, subscribe for deeper investigations like this one. Because out there, past the moons, past the ice, past the silence, the universe is still speaking. And Pluto might just be the first to answer.